Good evening to all. In this video, I am going to solve some problems for the transient and steady state analysis. So already we solved one problem for the RL circuit. So here also it is like RL circuit only. This is problem number 2. It is given in the GATE 2017 in the electrical engineering branch. The question is, the switch in the figure below was closed for a long time. If it is open at t equal to 0, the current in the inductor of 2 Henry for t greater than or equal to 0 is. So given circuit is this one, and here this is the switch which was closed at the initial condition and which is going to be opened at the final condition. Not final, it is a final condition but initial final condition, that is t greater than or equal to 0 means 0 plus. Okay, so we have to find the current through the inductor for t greater than or equal to 0. So we will solve the problem. So here I have drawn the circuit again. So let me solve. What is the initial condition? S is closed. Switch is going to be closed. So initial condition is switch is closed. Switch is closed means at that time for the DC network, this inductor appears as a short circuit. Inductor acts as a short circuit. If capacitance is there means capacitance acts as an open circuit. We know that. So we can short circuit this inductance and we can find out the current value. Okay. So let me draw the circuit again. So the switch is closed. So 6 ohms and here 8 ohms and this one is resistance is like this. So this inductor is short circuited now. So now this is I of 0 minus. What is initial condition? It is t equal to 0 minus. So I of 0 minus, here it is 32 ohms and 8 ohms and here also 8 ohms. This is 6 ohms. S is closed, 50 volt. So when the terminal is short circuited, these two resistances, we can discard this two resistance because current will be directly passed through this short circuit. So again we can redraw the circuit as these two resistances, 32 ohms resistance can be discarded and it will be like this. So this is, here it is 50 volt and 6 ohms, here 8 ohms and this is I of 0 minus. We have to find I of 0 minus. So we can find the total current easily because here 8 ohms and 8 ohms are in parallel condition. So when the resistors are identical and if it is in parallel condition means R by 2. Its equivalent will be equal to R divided by 2. Okay. So here R is 8 ohms which are in parallel condition. So for the parallel equivalent it can be 8 parallel with 8 plus 6, that is equal to, what is R equivalent here? 8 parallel with 8 plus 6. So 8 parallel 8 is 8 divided by 2, 4. 4 plus 6 equal to 10 ohms. Okay. So total current I equal to 50 by 10 which is equal to 5 amps. This is I equal to 5 amps. So 5 amps can be equally divided into two parts because resistance has the equal value. So 5 divided by 2 we can directly write as I of 0 minus equal to 5 divided by 2 is 2.5 amps. Okay. So let me take this as I naught, current at the initial condition, 2.5 amps. Okay. So we will find current through the inductor for the t greater than or equal to 0. So for t greater than or equal to 0 or t equal to 0 plus, switch is going to be opened. When the switch is opened, the circuit will become, so this part we can remove and only this part of the circuit will be there. So we can redraw the circuit. So it will be resistance and here also on resistance and here also on resistance. Okay, here on inductance we have to find the current through the inductor. So this is 32 ohms, 8 ohms and 8 ohms. So we can rearrange this circuit as 8 ohms and 8 ohms, that is 8 plus 8 16 ohms and here 32 ohms and here 32 ohms, 32 ohms, 32 ohms and inductance. So no voltage source is there. So no current will pass through this. We have to find the current equation with the initial condition of value. Okay, so here 32 ohms and 32 ohms are in parallel condition, which is in parallel condition with 16 ohms. So here L equal to what is the value given, 2 Henry. So here also 2 Henry. So now we will find the time constant tau equal to L by R equivalent. So here L value is 2, R equivalent is 32 parallel with 32, which is in parallel with 16. So two resistance are in identical. So 32 divided by 2 is 16. 16 parallel with 16, that is also identical. So 16 divided by 2 is 8. So 2 by 8, that is equal to 1 by 4. Okay. So here at the final condition no current will be there. So we can write the equation directly as I of t, current through the inductor, equal to I naught e power minus t by tau. So what is the I naught? Current at the initial condition we have found out as 2.5 amps. So we will substitute that 2.5 e power minus t by tau. So tau is substituted here. So it will become minus 4t. 2.5 e power minus 4t. So this is the current through the inductor at for t greater than or equal to 0. So thus we have found out the solution for current for the RL circuit. Okay. So let me solve the second problem. So see here. See here, this is the problem given in the year of GATE 2012. So it is given in EE and EZ code, both. Okay, it is given for 1 marks. What is the question? In the following figure, C1 and C2 are ideal capacitors. So in the previous problems we have solved for RL condition. So here we are going to solve for the capacitance condition. So in the following figure, C1 and C2 are ideal capacitors. C1 has been charged to 12 volt before the ideal switch S is closed at t equal to 0. The current I of t for all t is. So here they have given the circuit with two capacitances C1 and C2. So what is the initial condition? Initially itself it has been charged to 12 volt. Before the ideal switch S is closed at t equal to 0. So initial condition is opened only, but at that time itself C1 has been charged to V0 is 12 volt. Okay. So we will solve the problem. So what is the initial condition? So let me solve. So C1 is initially charged. C1 is initially charged to 12 volt. So positive potential to C1. Okay. This is 12 volt and C1, C2. Okay. Has been charged to 12 volt before the ideal switch S is closed at t equal to 0. Okay. So here 12 volt. This can be converted into S domain first, S domain network, because we have to find the current I of t for all t. So first we can convert into S domain network. Then after finding the equation we can take the inverse Laplace transform. Okay. So after converting, this will become so this for voltage 12 by S, and this is 1 by C1S, and this is 1 by C2S. Okay. So let me write the equation. Current I of S. Let me write the equation. So 12 by S, 12 by S by KVL, Kirchhoff's voltage law, 12 by S plus I of S divided by S into C equivalent 1 by SC, C equivalent equal to 0. So here C equivalent, here two capacitances are in series condition. So series condition means 1 by C equivalent equal to 1 by C1 plus 1 by C2. So we can substitute that. So 12 by S plus I of S by S into C equivalent is 1 by C1 plus 1 by C2 equal to 0. So after substituting this, 1 by S equal to into 12 plus I of S into what is this? C1 plus C2 by C1 C2 equal to 0. So I of S will be equal to minus 12 into C1 C2 by C1 plus C2. So what is, from this we can find I of S is